Well, thank you. I want to thank everyone for taking the time to join today. I really appreciate it. Please let me know if I need to speak slower or faster for the translation. It's going to be recorded, so you can always come back to it. And I'm on the call from my company. My name is Laura Deker. I'm with Microbiometer. And also on the call is Marissa Flannery, who is our soil scientist. I prepared a PowerPoint, and I really should have translated it into Spanish. I'm sorry about that, poor planning, but we can have that done, and I will send it in so you can look at it later. Is it okay if I start the presentation?
No, no se ve aún. Ahí fue, ahí está. Listo.
Okay. But can everyone see the presentation? There we go. Okay, sorry. My name is Laura Deker. I'm calling, like I said before, with Microbiometers, and we're going to do a quick talk today about the role of microbes in soil health and in agriculture. As you all know, I think you're all from agriculture. The growing trend is that growers are becoming essentially researchers as they learn to better grow crops and food, both in terms of a health and environmentally point of view, but also from a financial point of view. I'm getting a message to unmute everyone. Hold on. There we go. I'm trying to unmute everybody. Marcos, is there a way to do that?
No sé si nos ayudas, Melissa, un poco. Sí se ve, o sea, yo estoy viendo ya la segunda, no, la cuarta diapositiva en realidad estoy viendo. No está en modo presentación, pero bueno, está bien.
It looks like I can't unmute people, but I am trying to. Is there a way to do that? It says I'm the host, but sorry about this.
Marco, parece que el micrófono de Melissa está desactivado. No sé si tú lo puedes habilitar.
Ok, ¿cómo está en la reunión? ¿Cómo ha ingresado a la reunión? Melissa.
Ahí está ahorita con la mano levantada.
Ok. Ya la segunda. No,
pedirle tú a Marcos, porque yo no tengo forma de decirle.
Pero bueno, está bien.
Okay, should I continue? Yes, okay, sorry about that. Let me pull up my screen. Can everyone see the PowerPoint? Yes, good, thank you. Sorry. So far in conventional agriculture.
Ingresa por el teléfono. Ingresa por el teléfono.
Ya, Walter, ya le habilité, perdón, doctora, ya le habilité a Melissa, ya podría hablar. Ya continuemos, por favor, la doctora ya quiere continuar, parece.
Sorry. Okay, I'm going to stop sharing the presentation because it's in Spanish anyway, so I think it's not that helpful to everybody. But I will talk about what's in the slide, and I can send it out later. So far in conventional agriculture, we've been relying on chemicals, so pesticides, herbicides, NPK fertilizers to generate more growth and better returns. As we've moved along in agriculture, we have discovered that that has deteriorated the soil and led to resistant bugs and pests that are resistant to the drugs we have. So we're having more and more problems with our crops. One of the things we've also learned is that if you feed your crops artificial herbicides, pesticides, and fertilizers, they become dependent upon them, so that if you don't increase the amount that you use each year, they don't grow as well. So it becomes a cycle where you have to spend more and more money on fertilizers. And as growers, we know that's a problem. The other thing we know about microbes is that they, if they're in the soil and can properly live, can mine the NPK and other micronutrients that you need to grow plants. So at Microbiometer, we're coming at agriculture from a place of understanding the role of microbes in soil to help us have better crops and also release our reliance on some very expensive chemical inputs. With a healthy microbiome in your soil, they will mine things in the soil, feed them to the plant, and the plant will actually feed the microbes the things that they need. It is a symbiotic relationship. So the plant feeds the microbes feed the plants. And microbes can mine lots and lots of things that fertilizers don't provide to a plant. And they do it naturally and pretty much for free as long as you're taking care of your soil. The key that we have is transitioning from conventional agriculture to a more regenerative agriculture is that it's very difficult at the beginning to sort of get that cycle going. So for you to have a healthy microbial population in your soil, you need to make sure that the conditions are right for them to grow. So a lot of the things that we hear about now in agriculture is putting in inputs that will help your microbes grow and do well so that they can go into the soil, mine the ingredients that the plants need, and feed the plant. Okay. Part of your job as growers and as agronomists is to figure out what needs to happen to the soil. How can you start to make the soil healthier so that you can have healthier crops? So things like improving soil structure will help you with water retention, so you're less likely to need a lot of irrigation. I had a slide here, but it's in English, I'm sorry. What we do know is that there's a lot of symbiosis between the two of them, the plants and the microbes. So I'll send a slide out later. It sort of talks about how they work together. One thing that we also know is that microbes are very small. Obviously, plants are quite big. We're very big. A microbe doesn't have a lot of DNA. So microbes need each other because it's a very complex bartering system. Microbe A will create chemical compounds that microbe B needs, and then microbe B will create compounds that C need, and they'll trade them between it. So one of the things when you're growing your soil health and structure is you have to make sure that your population is diverse enough to support all kinds of microbes. So while a microbe only makes one or two things, if you have thousands of different microbes making different compounds, they will barter with each other and also with plants. And that's how you get a lot of the micronutrients that make plants so healthy and are usually the cause of why people think that organic food tastes better. I am going to put the slide on. I just got a little message.
Yeah, Dr. Deker, I can help you translate the slide, okay?
So there it is. Okay. So here is a demonstration of the symbiosis. Let me turn on subtitles. This is a picture that shows the symbiosis between a plant. So a plant takes about 30% of its energy and gives it to the microbes in the soil. this again talks about the symbiosis between the two of them. This is a cell that talks about how bacteria, just like I said, they need each other in order to have all the things they need to survive. So the larger your community, the more the different types of microbes you have, the better your soil will be, and the more likely you are to have all the different components in your soil that can help your plant's immune system. We'll be talking about natural plant immunity in a minute. This slide talks about interdependent populations. So again, the first slide, you can see there's nothing growing. On the second slide, you can see over time, there's lots of different microbes that start growing. And the different microbes start growing because each microbe can stimulate the growth of another microbe by feeding it. So this is on the assumption that there are sort of spores in all the soil. And as the conditions become ripe, microbes can come out and begin to live. The other thing that microbes do is they release plant growth, or plants release, microbes release plant growth promoting bacteria. Plant growth promoting bacteria are bacteria in the soil that stimulate plants to grow, in particular for their roots to start growing. So this root growth is one of the things that helps build soil structure, helps build soil organic matter, and improves water holding capacity. So if you have these bacteria in your soil, they will encourage plants to grow, okay? And in particular for roots to start growing. Soil structure is another matter that's incredibly important to farmers. Microbes build soil structure because as microbes live in soil, they excrete a sticky substance so that they can adhere to soil particles. And what that does is present that crumbly soil structure. So for those of you who are in agriculture, if you've gone to a field and you have that very deep, rich, sort of sticky soil that clumps, that's because the microbes are making these little soil homes, right, that can be filled with air and water so that they can live. Microbes need air and water for the most part, although some microbes don't need air. So as microbes build soil structure and reproduce, they create more and more of this structure. The result is you have better aerated soil and soil that can hold a lot more water. The soil aggregate cycle is a cycle where microbes make little homes, they sort of die, and then microbes continue to grow little homes. So the point of it is that as they build these little colonies to start living in, that promotes root growth, aeration, water infiltration, and as the roots and the microbes die, their remains becomes organic matter and carbon that is then stored in the soil that can be eaten and consumed by later generations of both roots and microbes. So as you begin the cycle of having more microbes, right, and a big diverse population of microbes, you will get through plant growth promoting hormones, more root structure, more plant growth, more soil structure with these little homes that have air and water in them. And as that continues to go, the old roots and the old microbes will do a foundation that will feed the next generation of plants. That leads to microbial food security. So microbes eat the soil organic carbon from plant material. Microbes both break down old plant matter, and also they themselves, as they die, become soil organic matter and carbon. So in soil, there's both soluble, which is considered fresh soil organic carbon, and stored or stable soil organic carbon. both in the healthy ecosystem are needed. Fresh soil organic carbon is sort of the sugar and the junk food that microbes and plants can eat readily. The stable organic carbon is stuff that's a little bit harder to get, but is incredibly necessary, particularly when there are stressful cycles. Microbes increase sort of food security in soil. If you think of soil as sort of a living community, you need to have lots of stored carbon and organic matter for them to eat. So when we think of chemical fertilizers, it's almost like just eating some sort of junk food or fast food. It doesn't really help you have more reserves in the soil. One of the things regenerative agriculture does a lot is talk about cover crops. So one of the big tenets of it is no bare soil. The point being, in order to keep the cycle of microbial life going in the soil, you want to have things growing most of the time. And so one of the things that people try to do is figure out what cover crop is the best. The goals of a cover crop are manifold. One, you want to increase the microbe community growing and getting more diverse. You want to put more roots and old plant material into the soil so that later generations of plants and microbes can eat it. And you also want to prevent, frankly, erosion from water and wind. This is a presentation that just shows in a given plot of land, different cover crops and the microbial response. So there's wheatgrass, a mix, clover, hairy vetch, and winter rye. You can see in this particular example, clover increased the microbial community the most. Now that does not mean that clover is good everywhere, but if you study the soil microbes, okay, it's not working, huh? I just got a message. Marissa, which slide can you see?
We are in the plant microbial symbiosis.
Okay. Do you
I
have
think
this?
it's number 8.
It should be on why you want an optimal microbial biomass.
No, we are on the plant microbial symbiosis. It's the number 8 slide.
Okay. It should be 17, sorry.
Oh, it's freezed.
Okay. Let me try this again, sorry.
It's okay.
Melissa, no sé si le puede por favor sugerir que comparta toda la pantalla, porque esto normalmente pasa cuando comparte solo una pestaña, digamos.
Okay. So Dr. Deker, what Marcus is telling me, if it's possible that you can share the full screen, because when you put all just one part of the screen, your slide, it doesn't move forward. But if you
Does that show?
But if you reproduce it the full screen, then we can see when you go forward. Yeah, that's
Okay.
right.
Can you see why you want an optimal microbial biomass?
Yeah, right.
Okay, good. I'm going to go
Thank
forward.
you.
Can you see quorum
Okay.
sensing?
Yeah, we're good.
Okay, I'm sorry about this, everybody.
No problem.
You think through COVID, I would have gotten better at it. So thank you for your patience. Why you want an optimal microbial biomass? An adequate population is required for a lot of microbial functions. We will talk about quorum sensing next. Microbes can make nutrients like NPK available that don't show up in chemical tests. And microbes essentially contain all the nutrients that a plant needs to survive. So quorum sensing is sort of a complex system, but I'll give you a little bit of an intro to it. Essentially what quorum sensing is a function of bacteria. And so if you have, so bacteria, some are sort of good and some can be harmful in certain quantities. So in any given community, in your body, for example, or in the soil, there are some pathogenic microbes, right? But they don't create problems because they're essentially held in check by other microbes. But when something gets out of whack, things get stressed, or there becomes an influx of conditions that are good for these pathogenic microbes, they start reproducing quite quickly. Once the microbe community of these sort of pathogenic ones gets big enough, they actually communicate with each other just like an army would and attack and create infection. So the best example of this would be you, right? You are covered in bacteria all the time, some of which can cause infection, but they don't. But if you become immunocompromised, or you get a cut that stresses your skin, those bacteria that are already on your soil can go in and create an infection. So when we talk about having a diverse and large microbial community, it's so that the microbes can essentially self-regulate themselves so that you do not get breakthroughs of pathogenic microbes. Now, of course, plants and people always do get sick, but you can keep the incident rates down. The next question people always want to know is, what level of microbial biomass should I have in the soil? And that depends a lot on your soil. It depends on the soil composition, what it's made of, sand, silt, clay, the pH of your soil, both naturally and because of what you've been doing to it, if it's high or low, compaction in your soil, either natural or created by farming practices, the amount of stored organic carbon, both fresh and stable, that you have in your soil. Of course, the temperatures in the season, microbes fluctuate in a very cold climate. In the winter, they'll go down. When plants start growing, they'll go up. Salt and other chemical levels in your soil, both naturally and created, your crop history, and of course, water availability. An organic or sustainable system is deeply reliant on the microbial community for immunity to pathogens. Microbes can play a very active role in keeping down pathogens and fighting pathogens in crops. Now, they're not going to obviously make all pathogens go away, but microbes and plants do communicate back and forth, and microbes can help plants be more robust and resistant to pathogens. Microbes provide plants and minerals and nutrients to crops. They digest old roots and organic litter. They actually communicate, plants and microbes communicate with each other about soil conditions, pathogens, things like that. As we talked about, microbes create soil structure. Microbes help protect against erosion. And of course, they sequester carbon into the soil in both forms of their sort of dead carbon and in organic matter. That is sort of it for the presentation. Here's our contact information. Let me get out of here. One thing that I'm here to talk about is our product, the microbiometer, and I hope that wasn't too much information, background information for people. I want to make sure but once you understand the importance of microbes in soil, part of what you want to do is test for microbes to see what is your level, what impacts your level, and what can you do to improve it. So our product, that I don't know how familiar you are with it, is called the microbiometer. It's a little kit, and it enables growers and other people to test the soil directly to figure out their microbial levels. You just use a cell phone and follow the instructions. And unlike me, they're translated into Spanish. So you have a full Spanish website, and the app is in Spanish. And you can use it to test your soil to see what is happening in the soil. If I'm using different products, are my microbes going up or down? and go from there. I know that Walter had done some testing on a lot of the crops to see the difference in the microbial content through there. What you want to do as a farmer and a grower and agronomist is combine biological tests for microbial biomass with other tests of chemicals and other metrics. So how are my crops doing? How is the yield? And combine it to tell a full story of what's happening underground in your soil. So I want to make sure I'm taking good use of everyone's time. So I think I went through a little bit of the microbes and a little bit of the microbiometer. But if I could get some more guidance, maybe Marcos, on what I can talk about next, or if you want to take some questions from people, that's fine too.
Marcos, la doctora Deker está preguntando si ha quedado clara la charla acerca de los microorganismos y si pues en este momento desean hacer alguna pregunta o si desean que ella hable acerca de algún otro tema.
Ya, perfecto. Sí, pues escuchémoslo a Manuel Gallo y por favor ayúdenos traduciendo, ¿ya? Adelante, Manuel Gallo, le escuchamos. Vamos a ir en orden porque hay 2 o 3 personas con las manos levantadas. Ahí activamos los micrófonos para que por favor abra el micrófono y participe. Manuel, le escuchamos. O Fausto Falconi.
Hola.
Adelante, Manuel Plugas, adelante.
¿Cómo está? Buenas noches, gracias por la invitación. La pregunta es la siguiente. En mi caso, yo tengo cultivo de mango y no hago aplicaciones con químicos, simplemente corto la maleza con guadaña, dejo que la maleza quede sobre los árboles, o sea, bajo los árboles, y las hojas de la poda también quedan en los árboles. Me gustaría saber cómo podría mejorar mi flora microbiana en este caso.
Ok, me está indicando que usted tiene cultivo de mango, no realiza aplicaciones químicas, solo corta la maleza y me está diciendo acerca de las hojas que me mencionó.
Las hojas de la poda también yo las pongo bajo los árboles para que se descompongan. Pero me gustaría saber cómo aumentar mi flora microbiana para tener porque yo estoy en un suelo que es arcilloso, entonces me gustaría tener una mejor descompactación para mejorar las raíces.
Okay.
Okay, the translation worked very well for me.
Okay.
Is that okay? So first of all, that's terrific. I think leaving the organic matter on the ground is a fabulous way to do it. In terms of compaction, I think there's a lot of factors that I couldn't speak to. I don't know if Marissa, who's with us as a soil scientist, can have some ideas. But in general, if you're trying to deal with compaction and improve microbes, sometimes some sort of tilling is a good idea. You have to be a little careful of it. And then sometimes putting in a microbial stimulant is warranted. So this is sort of, usually there's an algae product or some sort of product that will provide initial food for microbes to start their reproduction again. But again, it's a little bit more complex. I'll see if Marissa wants to chime in, or if people on the phone have ideas who are more familiar with those crops, that would be a good point for them to discuss.
Dr. Deker, I'm just helping translator because I'm not a grower. Sorry for that.
Escuchemos.
So I unfortunately didn't, my translation captions are not working, so I didn't understand the question. but I did hear your answer, Laura.
Yeah, so he's just asking, he has a mango crop that he doesn't put anything on. He just trims the trees and leaves the organic matter to decompose. He's wondering how to improve the microbial community and deal with compaction in clay soil.
Yeah, some soil does need a little bit of tilling. The concept of no-till is more of a general practice, but if you speak to a lot of regenerative consultants, they'll say sometimes tilling is definitely needed to break that compaction up.
Yeah, but a local agronomist or someone who has similar crops to yours might have some ideas. If you use a test like the microbiometer or have a microscope, you can test over time your soil to see, you know, what's happening with the microbes. Are they going up or down? Or if you use a new product, is it helping? That work? Are there other questions?
Sí, escuchémosle, por favor. Fausto Falconi, ¿desea hacer su pregunta? O si no, Mark.
Ok, gracias. Hola a todos. Sí, la consulta es, estoy dejando la fertilización sintética y estoy iniciando un manejo con lo que es materia orgánica, microorganismos benéficos. Allí la consulta es cada que yo hago la incorporación de tricodermas, por ejemplo, Bacillus subtilis, lo estoy acompañando de melaza. Entonces la consulta es si esto me ayudará en la vida de la flora microbiana o a la vez estoy causando alguna alteración y hay que aplicarlos solos a estos, ya que en estos suelos he tenido presencia de Fusarium y Pythium. Entonces, por ello que estoy tratando de neutralizar al patógeno. Entonces, si hay alguna recomendación sobre este punto, pues quedo muy agradecido.
I'm sending my translation to Marissa. We're working around it. Basically, just asking about specific pathogens in the soil.
Yeah, so it's hard to know specifically what to say to try to neutralize a certain pathogen in your soil, especially Fusarium. There's a lot of different specific species of Fusarium that can have a different, that need different management. I have read in the past that a lot of, that sometimes intercropping can work with certain medicinal tree species, that if you, I don't know which crop this was in reference to, but if it was the mango tree for the last example, then you have mango trees and then maybe plant another type of medicinal plant that helps inhibit certain types of Fusarium, that in combination with other types of pathogenic resistance methods could potentially help.
Yes, I'll also encourage people if you open the chat, if you have suggestions or references, you can put in the chat for each other. You guys are all from the same area, so probably your local expertise and knowledge might be a little bit better than our sort of theoretical knowledge. We're in the United States, so some of what we say, you know, it won't be as helpful.
Ok, el cultivo, olvidé mencionarle, es ornamentales, por eso es que tengo presencia de Pythium Fusarium en este caso.
It's ornamental, and they have the presence ornamental plants.
Okay.
Thank you.
Yeah.
Escuchémosle a Manuel Gallo o Glenn Anderson, que esté listo, active su micrófono y adelante, le escuchamos.
Hola, ¿qué tal? Buenas noches con todos. Muchas gracias por la invitación. Y bueno, pues la pregunta es la siguiente. Lo que pasa es que yo tengo cultivo de cacao y la problemática en este caso es la moniliasis. Yo apliqué un producto químico que el ingrediente activo es mancozeb. Entonces prácticamente no le benefició en nada. Entonces quería saber si hay un tipo de microorganismo que ayude a bajar los daños en la mazorca, porque hay mucha pérdida. Entonces, esa es mi pregunta.
The question is, it's cocoa is your crop?
Cacao.
El
and
cultivo es en cacao. El
Okay,
cultivo es en
cacao.
cacao.
Yeah. And you're looking to see what microorganism would help. Again, there are likely in the area numbers of amendments and inputs that could be beneficial based on the crop and type of soil. But an agronomist who is there might be more helpful. Again, if there's anyone in the audience who has some suggestions that might be more helpful, to sort of share what you have.
La doctora Marissa puso en el chat que es un poco difícil determinar, pues, ¿no? Los tipos de patógenos específicos, ya que ellas no conocen a totalidad el tipo de suelo que tenemos acá.
Okay,
Yo tengo una pregunta.
El tipo, perdón, disculpe que lo interrumpa.
Te decía, a mí me interesa saber si es que el uso de biocarbón puede incrementar la masa orgánica en suelo. Hemos hecho algunas pruebas, algunos trabajos, incluso el uso del biocarbón para hacer compost chart, es decir, compost con biocarbón. Si me puede o tiene experiencia sobre el uso del biocarbón para incrementar la población microbiana del suelo.
Yes, but the question is about the experience of biochar in soil. We have worked with a lot of people who have used biochar, both in compost and directly into the soil, and many of them have had terrific results. We don't quite know because we haven't done studies why, but it's very clear that biochar can increase the amount of stored carbon in your soil that can be a long-term food source for microbes. So biochar is one of those products that is pretty exciting for people, and a lot of people have had very, very good uses. But in a particular example, you see if it's how much and if it's good for you.
On the other hand, I have another question. What about the use of biochar plus compost, or compost start with biochar to improve the microbiology population?
Yeah, absolutely. So compost is another thing, particularly locally made compost is considered quite good because the microbes that you have in a given area eat the things that are in the area. So compost with biochar or putting down biochar and then compost have had very, very good results, as have many algae amendments that have both microbes in them and microbial food. I know in the Southwest, in very desert areas, people have had good luck with algae or seaweed-based amendments.
Thank you.
Adelante. Adelante, Santiago Amador Sánchez.
¿Qué tal? Sí,
escuchamos,
buenas
Santiago.
noches, querido Marcos y doctora y la señorita Marissa también, y todos los participantes. Nosotros tenemos un gran problema ahorita en Latinoamérica, se ha visto tanto en Costa Rica, Colombia, Ecuador, el tema del moco, el Ralstonia solanacearum, que está atacando las bananeras y poco a poco hay más contaminación. ¿Qué nos podría recomendar, doctora, con esta bacteria patógena? ¿Cómo la podríamos contrarrestar? ¿Cómo podríamos minimizar? ¿Cómo podríamos defender a nuestra plantación bananera o en general musáceas, tanto plátano, abacá, etcétera?
Just sending Marissa the picture. And this is about a specific pathogenic bacteria for in the banana crops. And again, because it's so specific, I think I couldn't offer specific examples. Marissa, do you have anything to add?
Yeah, so I know Walter mentioned specifically this banana pathogen that you guys are experiencing. Unfortunately, it's really tough for us to know, and I know it's a very widespread issue. A lot of different areas kind of are prone to certain types of pathogens. The main thing that I've read about that, which is it's not a lot, I haven't read so much about it, but is that it's difficult to get rid of course. So it's better to try to limit the spread more so and work off new areas. But again, I would think intercropping, so adding some type of, I think he said the bacteria was Ralstonia, if that's correct, if you guys know that. But yeah, I unfortunately don't have a specific method that could help remove that specific bacteria from the soil. Our test won't necessarily be able to tell you if that bacteria is present in the soil, but increasing your microbial biomass in general will help, as Laura mentioned in her presentation. It will help, what's the word I'm looking for? Like increase plant immunity, so it'll help kind of resist pests more and different pathogenic microbial species.
Probably you work with Bacillus amyloliquefaciens to control as you know, these bacteria control Fusarium, Aphanomyces, Fitium, and probably it can be controlled to Fusarium race 4.
Yeah, I would say doing, if possible, doing types of experiments. So if you know of local products that say have an influx or type of feed to feed the certain Bacillus bacteria, you can see if that is maybe lowering the amount of the moco disease in the bananas.
Yeah.
Yeah.
Podríamos decir o estamos diciendo que ciertos patógenos es difícil de controlar.
Yes. I just want to say something. We believe very heavily that having a healthy soil microbial population is very important, but it will not prevent all pathogenic infections and diseases. So a lot of people in agriculture now still need to rely on both control mechanisms for pathogens and crop disease, and also more traditional chemical and herbicide and pesticide treatments. So again, I'm sorry we don't have more firsthand knowledge about the issues, but there are likely growers and agronomists in the area who have tested different solutions. So your two-pronged approach that Melissa came up with is trying to make your crops and soil as healthy as it can be so that when you get a pathogenic attack, you can more easily treat it.
Escuchémosle a Alison Zapata, creo que tiene una pregunta también. Alison, le escuchamos.
Sí, buenas noches. Quería saber si ustedes han hecho algún monitoreo de aplicaciones de bacterias comerciales, de pool bacterianos comerciales, en el antes y el después con su equipo. ¿Qué resultados han tenido? ¿Cuánto aumenta esa biomasa? Biomasa de bacteriana y de microbios, pues no de bacterias y hongos.
Okay. My translation came out a little odd. Can someone summarize the question? Melissa, perhaps?
Doctora, ¿me puede repetir la pregunta, por favor?
Sí, buenas noches. Si han hecho, si tienen alguna data de alguna medición que han hecho del antes y el después con el microbiometer que el equipo que tienen, ¿en cuánto aumenta la biomasa microbiana al utilizar productos comerciales de microorganismos?
Okay, did you get the translation? You want my help?
Yes. Yeah, thank you. I have. Thank you for rephrasing that. Directly, what we do is we work with a lot of amendment companies who use microbial inputs, and they use the microbiometer to show how their product works in the field. We don't directly at this point, we're a very small company, do direct testing on microbial inputs. One, because there's thousands of them, and two, we are only located in one area of New York State, and so an input might not work where you are if it works where we are. So people have used the microbiometer to show that certain products and practices improve the microbial solution, and then also shown that their yield and crop health is better, right? Because that's really what you're going for. You want healthier, more productive land and better crops. So certainly on our website, we have a lot of stories about people who have used the microbiometer to prove out and to test early in the process what amendments are working. But again, it's a very local thing to see which one would work the best in your soil and on your crop.
Tengo una consulta adicional y disculpen que haga dos preguntas seguidas. ¿Qué piensan sobre el uso de amonio cuaternario o peróxido en los suelos para bajar patógenos?
I'm going to send this to Marissa. Sorry. And can you say again the two things? Ammonia and what?
Sí, aquí en el Ecuador, por el tema del moco que está afectando al banano, hay ciertos productores que están utilizando desinfectantes como amonio cuaternario o peróxido o agua oxigenada, aplicando los suelos para bajar carga bacteriana, sobre todo si tiene mucha incidencia de bacterias patógenas. ¿Qué piensa al respecto?
I'm sending it to Marissa to see. This is hydrogen peroxide applied directly to the soil or other disinfectants.
Yes, she's trying to know whether you think about that use in soil directly.
Yeah, I've never heard about that before. But it is, I could see something like that, some type of alcohol essentially, or something like that to kill that. I truthfully, I have no idea. I haven't heard of anyone around us specifically using that, but that's very interesting. I saw the comment said in El Salvador that that they're using that. Do you have a study for that, or is it do you know if it's effective? Well,
Yeah, I mean, the people listening in might have more information on this than we do, if they know of people who've used it successfully. People can use the message board to write in if they would like to.
Yeah,
Sí,
I can translate the messages in the chat easier than what's spoken.
Hay algunas personas que han escrito, si podemos leer las preguntas, algunas incluso están en inglés, o si las podemos traducir para contestar en el chat. Espero que se haya entendido. Yo tengo una consulta. ¿Cuál es la cantidad promedio o apropiada de microorganismos en el suelo?
Dr. Deker, so Dr. Marcos was asking, which is the ¿me puede repetir la pregunta, doctor?
La cantidad, soy ingeniero nomás, pero bueno, gracias. La cantidad de microorganismos adecuada en el suelo.
Okay, so he's asking which is the quantity average of microorganism in the soil.
Yeah, so in agricultural soil, it runs between about 200 micrograms of microbial carbon to about 800 micrograms of microbial carbon per gram of soil. That's the metric that the microbiometer reports in. 200 is normally quite poor soil, and 600 is very, very healthy soil. We have found that for the most part, if people are between 400 and 600, they have fairly robust soil. Again, a desert climate compared to an equatorial rainforest would be much different. But it's fairly clear that under about 200, it's quite difficult to have a viable microbial community. You can still grow plants, and people still do, but it's often much more difficult and much more dependent upon chemical fertilizers.
Gracias.
And on our website, Microbiometer, which translates to Spanish, you can read more about microbial levels if you go to the blog and search for it.
So, Dr. Deker, we have a question on the chat from Danilo Carrion. He's asking which is the more effective microorganisms used on infertile soil and also contaminated with the herbicides.
So say that again. What is the
most effective microorganism used in infertile soils and also the soils that have been contaminated with herbicides?
And Marissa can jump in as well. Often you don't need to put in microbes. Microbes are in the air and in the soil already. A lot of what people believe now is that you just need to make the soil conditions better. So you need to make sure there's cover crops, that there's perhaps intercropping. Perhaps you have to put in microbial food, so an algae input to encourage it. And at times people have to do tilling if their soil is very compacted. In certain areas, there are microbes that are very beneficial to put directly into the soil. But that would take a very specific analysis of what's going on with that soil, what the problem is, where you are. Marissa, do you have anything to add?
What was the initial question? I'm sorry, I was looking for it in the chat with the vertisol soils. Just like, what is a way to kind of reduce that, Laura? Or
It was just a general question about what if you have soil that's been treated with herbicides, is there any microbes you should put into it?
Oh, any specific types? Yeah. Kind of like Laura said, just kind of creating that ideal habitat or ecosystem for those beneficial microbes. So, all soil has a mixture of both beneficial and pathogenic microbes. So they're kind of all in balance, and the good ones keep the bad ones in check. So as long as the good ones are being supported, essentially, so there's enough aeration going through the soil, there's enough water, the pH isn't off, you are planting specific cover crop, you're being intentional about the cover crop. So perhaps a certain time of year, you take a nitrogen test, or you notice that's low. So then maybe you would plant some clover, or I don't know specifically for Ecuador or truthfully South American regions, but certain nitrogen fixing plants, cover crops for that. And then, so just essentially creating a good ecosystem for them to flourish, and they will kind of do what they're supposed to, as long as they're being supported in the correct way.
Oh, okay, thank you. There's a recent question on the chat. It's already in English, but I can read it for you. Is there a rapid test for detecting beneficial microorganism in agriculture's soil?
Not that I know of.
Not that I know of. Our test is all microbes. There are beginning to be DNA tests. So you can take tests for very specific pathogens, right? What are they? What's the company called? Oh,
B-Crop.
B-Crop. Biome Makers is a company in the United States that is now doing specific DNA testing on microbes. It's quite expensive, I'll tell you that right now, and it's early in the process. But just to kind of know if you have pathogens in the soil, there's none that we really know of that would sort of give you, unless you had an idea of what you were looking for. And certainly if you know how to use a microscope and identify bacteria, you can do that as well.
Yeah, I would say a microscope is probably the quickest way to determine that, or if you're, if anybody's close to or have connections with universities in their science departments, usually professors in there, there's, bound to be some microbiologists who would potentially be able to look through a sample, but a rapid test, I don't know any of us around here. There's other types of tests, different types of rapid tests that you can use to kind of, get a more well-rounded view of your soil. So if you do multiple types of rapid tests, you could potentially see, but nothing specific.
Okay, thank you. So we have another question about coffee and cacao crop. They're asking if you know about which product to fumigate so the leaf don't die and they have a really wonderful and beautiful production on cacao and coffee crop.
Again, that's very specific agronomy that we I'm sorry to say don't have that knowledge.
Okay, don't worry. Thank you.
Okay, I wish I did.
It looks like Walter asked, what does the fungi, the FTB ratio tell us, and what are the values that we should expect as normal? I know you went over the MBC values, Laura. Did we mention fungal?
Oh yeah, we didn't mention fungal. So in general, agricultural crops, people aspire to at least a 1-to-1 ratio. And in some crops, they want higher fungal content. Marissa, you can talk about that a little bit more, but usually below a 1-to-1, it's a little too bacteria dominant, and people will try to figure out what practices can grow more fungal content.
Yeah, some groups of people will say that certain types of vegetables or crops that you're growing require a certain fungal to bacterial ratio, which, very well may be true. But we don't necessarily promote the concept of having a specific fungal to bacterial ratio for a specific type of crop. It just really depends on your farming goals, and all the different factors in your soil really do play a role in it. There's not really quite, if you're growing bananas, you're not looking for a 0.5 to 1 ratio or anything specific that we could say. I would think it's more of an experimental thing. So if you are noticing if your fungal to bacterial ratio of the banana tree is very low and it's not doing well, and then you use certain products and inoculants to try to raise the biomass, and then the fungal to bacterial ratio does increase, and then you can see that the banana plant is actually doing better, then perhaps that is, you'll know that range is good for your soil in that condition.
Okay, thank you. Also, Walter is asking if the microbiometer allows to plant microbes inoculants application. Applying.
Say that again, it cut out, sorry. If what?
If the microbiometer allows to plant microbes inolines applying.
So basically, I think he's asking if you can plan application of future, fertilizers or inoculants with the test, and you can't. It won't necessarily tell you when to do that, when you should apply your next round. Again, our test is better when you can kind of run experiments on it, so that you'll know. You test it in, let's say, at the end of April, you do a test for your field, you get your results. I'm not sure exactly when you would apply, certain inoculants and fertilizers for specific plants. But say in May, you would do that. And then in July, and you would do it again at the end of the harvest. So certain times will depend, will play a role in what your results are. So it is best if you can do testing, kind of get a baseline result for each season, since microbes have a natural fluctuation. And then that will help you better plan for the future of how much you would need to do based on just our test.
Okay, thank you, Marissa. So Daniel is asking, which are the microorganisms more used on your country's crop?
Honestly, nowadays people are making products with a lot of different microbes. It would be hard to say a specific kind of microbe, especially we don't work directly, as we're not agronomists, so we're not consultants. We're not consulting with farmers on which products they're using. We're more so providing them the test that will help show them, just one factor in helping show them if that product is working.
Yeah, this is Laura. In the United States, they're called biological products. There's literally thousands of them. And some are specifically designed for, say, corn, or some are specifically designed for the Midwest. So again, they're very local. It's early in the industry, so there haven't been any that have come out as really sort of the best everywhere. Unfortunately, that makes a lot of work for all of you to figure out what is there. But if you start looking at the biologics and talking to people in your area with your same crops of things that work, that's probably the best way to figure out what might be a good fit for you.
I know a lot of the farmers we speak to are looking to increase their fungal community in their soil. So because they specifically want to increase their fungal community, a lot of them have been saying that they will kind of use local compost or create their own and put worm castings and different, wood chips, different types of organic material into their compost, and local organic material too, and mix it with their soil, and then create a compost tea or extract, and then spray that on the soil or use it as a foliar application. I know a lot of farmers, they have their own mixture of things. So if you ask them, they'll tell you a million different things. But again, it works for their area. So someone in a small area in Pennsylvania, they're using their community's compost and it's doing wonders. If they use that same thing in California, it might not work the same way. So more of a local approach seems to, I think, be beneficial for the soil.
¿Cada qué tiempo sería recomendable hacer una aplicación de microorganismos en el suelo?
Marissa is asking, what time would it be most advisable to add microbes to the soil? Again,
I would say, yeah, it depends on the specific crop and the life cycle that they're in.
It's likely that the product you're using has recommendations. Some of them you want to put in right before planting, and some are designed to be, put at some point in the growing cycle. So it would depend on the product, essentially.
Ok. Ayúdenos, por favor, con la página web del instrumento en el chat.
Yes.
No sé si hay alguna otra pregunta de los participantes, alguna otra duda. En términos generales, un poco lo que ya sabemos, posiblemente los microorganismos, pues, o ir apuntando a lo ecológico o en ese sentido la producción amigable con el ambiente, nos favorece en todos los sentidos, pues, ¿no? Como bien dicen la doctora Deker y Marissa también, que me parece que es doctora, no hay alguna solución específica para tal o cual cosa, pero sabemos que un suelo sano nos va a dar mejores resultados en cualquier cultivo en realidad, ¿no? Adelante, Santiago, le escuchamos.
I'm putting it in the chat.
Ahí
Ya,
Santiago.
¿qué tal, ingeniero Marcos, doctora? Sí, bueno, yo me gustaría saber, cuando hablan de inoculación y también hablan de varios formulación casera o artesanal que hacen en diferentes partes, creo que nombró Pensilvania y California. ¿Cómo hacen para darle lo necesario nutricionalmente al cultivo? Es decir, los macro y los microelementos para que haya una producción óptima. ¿Y cómo es el sistema cuando lo acompañamos con los microorganismos? ¿Cómo es esa sinfonía, esa sincronización? ¿Cómo se la lleva en sí? Según lo que acaba de decir la doctora Marissa.
Oh, it went away. I was reading it. Sorry.
Ayúdenos, por favor, Melissa, con la traducción.
Repite, por favor, la pregunta.
Ya, cuando habla mucho de las experiencias tanto en Pensilvania y California que hacen estos productores abonos casero o artesanal, ¿cómo hacen el llenado de la necesidad de microelementos nutricionalmente hablando para que el cultivo sea con rendimiento óptimo? ¿Cuál es la sincronización entre microelementos y los microorganismos?
And who, is that a question for us, or is there someone specifically in Pennsylvania that you were referring to?
Yeah, it was a question for you both. He was asking based on Dr. Marissa answer about Pennsylvania and California, when she was telling about those when they're asked about the microorganism more used on your country. So what he wants to know, it's which is the synchronization about microelements and microorganisms.
So how do the people make the mix so it's perfect? Is that sort of the question?
Sí, correcto, esa es la pregunta. ¿Cuál es la sincronización de microorganismos y microelementos para que la producción sea óptima o alta?
Okay. Marissa, you can jump in too. At this point, people are experimenting. So they try different things, and if their crops do really well, they assume it works. Marissa, you can jump in. It's new in the science. So I don't think anyone has there's not some sort of playbook onto what people need to do, I think. Marissa, I'll see if you have anything to add.
Yeah, no, specifically the farmers that I was kind of referencing, they are making many different batches. So they're taking their compost and making it into a tea. They'll do the same thing again the next day, and the tea, he can say, like, the farmer will say, oh, they're different colors, and they could tell, like, oh, they put a little more of this microbe in this batch, and different. They're just trying different things. So in one batch they'll add something, in another batch they'll remove it and try different things. And because they have a big farm, they're doing different experiments to see, okay, if I apply product A on this section of my trees for 1 week, and then I wait a month and I compare it to product B over here, but the same landscape, you always want to compare apples to apples. So they're always doing that. So they're basically trying a lot of different experiments is all. That's the only way for them to know what works, because a lot of the farmers, they're not scientists, they don't know. They're not spending hundreds of dollars getting their soil tested for specific types of pathogens or, fungi or bacteria that are in there. They can't afford to do that. So it's a lot easier for them, and you can visually see it too if your crop is producing more, having a larger yield, or not dying as slowly because of certain things. So it's definitely experimenting with different products and different inoculants. So you could notice a product works very well, and then maybe you want to combine the products. Maybe, again, community is a really big thing for the farmers around here. I would say in the United States, they would not be anywhere without their community. So, and communicating with everyone.
Hay una pregunta en el chat también, por favor, Marissa.
You're just asking what in general, the contribution of that bacteria to the soil? I don't know much specifically about it. I could do a quick search, and I'm seems like it is, a beneficial bacteria. When kind of Laura was talking about the PGPBs, plant growth
promoting bacteria.
Yeah. But yeah, plant growth promoting bacteria, that's definitely a big movement right now, is trying to feed those types of bacteria specifically in the rhizosphere, so in the root system, trying to increase those, because that will, of course, help the plant grow stronger. But there are hundreds of different types of plant growth promoting bacteria. So some are, nitrogen fixers, others are, other different types that would be more specific to a specific crop.
Estaba preguntando si el instrumento que ustedes presentan clasifica los microorganismos.
We don't report specific kinds of microorganisms or classes. Biome makers does classify bacteria or types of microorganisms, if you want to contact them.
Ok. Bueno, parece ser que hemos dado respuesta a todas las preguntas. Ahí está por ahí Marissa para despedir. Vamos a hacer un sorteo. Eso ya es una cuestión interna, doctora Deker. Le agradezco infinitamente, igual a Marissa, por habernos acompañado, por traernos ciencia, ¿no? O sea, un poco la idea con la población ecuatoriana que estamos, es dar a conocer que hay esta tecnología, que hay este tipo de instrumentos y que son importantes que los tengamos, pues, ¿no? Entre nuestros equipos. Muchos ya tenemos un pHímetro o un termómetro o algunas otras cosas básicas de campo, de profesionales o de productores. Y es sumamente importante también tener claro qué cantidad de microorganismos tenemos en nuestros suelos. Ese era un poco el sentir de este día, de este webinar, para transmitirle a la audiencia el tema. Yo, infinitas gracias, doctora Deker y Marissa, y también a Walter, que nos puso en contacto, y esperamos hacer algo juntos próximamente. Disculpen cualquier cosa, un poco por el idioma, posiblemente. No sé si nos puede ayudar Marissa con algo de lo que dije, o si entendieron todo en buena hora. O le escuchamos a Jorge.
Okay, so Dr. Deker and Flannery, we're really thankful for all your information, for all your knowledge. We really know that here in Ecuador, we do need equipment like you offer to us, because it's really important to know the microorganisms that are on the crops, and it's important for the growers to know what they have on their soil. So we really appreciate your time, all your knowledge, and all your disponibility in this webinar. And also, Dr. Marcos is thanking Walter to put it in contact. Now he's gonna make a giveaway. It's like an internal giveaway for all the participants. And once again, we really thank you for your time and your knowledge.
Thank you. I appreciate it. Good night.
Good night.
Thanks, everyone.
Thank you. Good night.
Night.
Bueno, antes de cortar, como se les había ofrecido y se les había indicado, yo voy a compartir mi pantalla. Vamos a hacer el sorteo del equipo que nos acaba de mostrar la doctora Deker, para que algunos de ustedes se beneficien. Adelante, Jorge Washington, te escuchamos hasta que yo comparta la pantalla. Marissa ha puesto su correo electrónico por si acaso, marissa@microbiometer.com, para que cualquier persona le pueda también escribir, obviamente, cuestiones del tema que hemos expuesto hoy. El sorteo no es un carro. Ojalá algún día sorteemos algún carro, ¿por qué no? Pero hoy vamos a sortear un instrumento o un kit para medir los microorganismos, que espero que les sirvan igual o más que un carro, porque al fin del día nuestros cultivos, nuestros terrenos son nuestros activos más preciados.
doctor Marcos, yo me retiro. Sí, muchas gracias por permitirme
Ok,
estar aquí.
ok, gracias. Muchas gracias por acompañarnos.
Gracias, hasta
Bueno,
luego, buenas noches.
esto, gracias. Básicamente, espero que estén viendo mi pantalla. Yo no tengo absolutamente nada que ver con este sorteo. El momento que se gane ya se pone en contacto con Alianza y ahí le derivan a la persona que le va a entregar el equipo. Esto es solo para ecuatorianos porque no vamos a hacer un envío del equipo afuera, al menos no por ahora. En todo caso, tenemos 209 personas inscritas y aquí, si usted se inscribió, seguramente está su nombre. Y lo más importante, si más tarde sale Yandri Mera y total no está en la sala, pues lo siento mucho, ¿no? Así es que vamos a ver cómo funciona esto de aquí. No, alguna vez ocupé sorteos por nombres al azar, es una aplicación, vuelvo y repito, no tengo absolutamente nada que ver con la app. He puesto todos los nombres de las personas que se han inscrito y vamos a ver cómo nos va. Ganadores 1, suplentes, pongamos 3 suplentes, porque solo es un ganador. Pongamos 5 suplentes por si acaso. Y creo que nada más. Confirmar. Ahí están todos los nombres de las personas que se inscribieron. Y comenzar. Vuelvo y repito, no tengo nada que ver. Esta es una aplicación automática de sorteos. Espero que se haya favorecido y sobre todo que nos ocupemos pronto. Freddy Cuarán. ¿Se encuentra Freddy Cuarán en la sala? Y es de Ecuador. Sí están habilitados los micrófonos, ¿no?
Sí, sí estoy.
Yes.
Sí, ¿está Freddy aquí? A ver, adelante,
Sí.
Freddy.
Sí, sí estoy.
Ya, perfecto. Espérese un ratito, no se vaya. Para que quede claro, ¿no? Ganador es Freddy Cuarán. Ya no tengo más nada que hacer porque está en la sala. Y es de aquí de Ecuador, Freddy. ¿De qué ciudad es usted?
Sí. Yo soy de Quito.
Ya, ¿en qué cultivo se desarrolla? ¿Es ingeniero agrónomo, es productor? ¿En qué parte de la cadena está?
Soy ingeniero agropecuario.
Ya, perfecto, perfecto.
Al momento, cultivos de cebada, pastos. Acá en
Ya,
la sierra.
¿cómo se enteró de este webinar?
En un grupo de nutrición vegetal, ahí nos facilitaron el acceso a este webinar.
Ya, perfecto. Para los demás, no se vaya Freddy y bueno, ya que se quiere retirar, no hay ningún problema. Tengo que igual hablar con Freddy, voy a hablar un momento más. Gracias a todos los que participaron, a los que se inscribieron, más de 200 personas y estuvimos en sala, igual un número parecido. Gracias a estas personas que quedaron, digamos que en tercer, cuarto y quinto lugar. Si estas personas están en sala, 1, 2, 3, 4, 5, yo les hago dar como premio consuelo el diploma o el certificado de manera gratuita de este webinar que acabamos de tener. ¿Está Vladimir Lagos en sala? Bueno, ¿está Tony Flores en sala?
Buenas noches.
¿Quién está hablando? Vladimir. Ah, ya, Tony. Sí. Luis Kiwango está en sala. Rubén Escobar está en sala y Pedro Chévez.
Sí, señor, aquí presente.
Ya, por favor, de las personas, esto queda grabado igual, ¿no? Igual voy a hacer un capture para mí. De las personas que hemos nombrado, para estar claros todos, Freddy Cuarán ha sido el ganador de lo que las personas que nos ayudaron a organizar esto de aquí, de muy buena fe, han querido colaborar. Y obviamente le vamos a hacer la entrega y vamos a hablar cómo lo vamos a llevar a cabo. Y las demás personas, Vladimir, Tony Flores, a ver, solo está aquí en sala, voy a anotar. Tony está en sala, ¿no?
Sí.
Ya, Tony Flores. Luis Kiwango. Vladimir Lagos. Roosevelt Escobar y Pedro
Sí, señor.
Cheo. A ver, ¿quién me habla? Disculpe.
Roosevelt Escobar.
Ya. Ya no importa si es de otro país, Roosevelt, porque tiene un acento colombiano, me parece, ¿o no?
Sí, señor colombiano. Gracias.
Ya, es necesario y muy importante, y si está Pedro, igual, comuníquese con el número de Alianza. Lo que vamos a hacer es lo siguiente. Déjenme dejar de compartir para hablar un ratito más. Ya, lo que vamos a hacer o lo vamos a llevar de la siguiente manera. Escriban el número de Alianza, que lo voy a volver a escribir ahorita aquí, con sus nombres completos. Lo voy a poner con todo para la persona de Colombia, sobre todo. 593, 0. Ya, ese es el número de Alianza Agropecuaria Ecuatoriana. Por favor, envíe su nombre completo, su número de cédula o DNI. Esto para Tony Flores y Roosevelt prácticamente. Y con mucho gusto le hacemos llegar, vuelvo y repito, como premio consuelo. Esto no tenía planeado, pero bueno, ya como salió sus nombres ahí y el primero salió, porque a veces pudo haber pasado que el primero no estaba y se ganaba el segundo y así, ¿no? En todo caso, se ganó el primero el señor Cuarán, me parece. Y Tony Flores y Roosevelt Humberto se han hecho acreedores también a Sofía, está triste. Disculpe, Sofía, no depende de mí. Al certificado. Entonces, agradecerles infinitamente a nombre de Alianza Agropecuaria Ecuatoriana. Por favor, ayúdenos a difundir, ayúdenos a compartir para seguir creciendo. Estamos llevando conocimiento, estamos llevando equipos que, como digo, son relativamente modernos o nuevos, incluso todavía están bajo investigación. Y la idea es seguir creciendo. También, evidentemente, los equipos los venden, pero nosotros no hacemos el área comercial, ni mucho menos, ¿no? Alguna persona, porque está preguntando cómo es el equipo. Les invito a que veamos, ahí nos pasaron la página, bueno, Microbiometer se llama el equipo. Y creo que es importante que tengamos, me parece que es relativamente accesible el precio, no es barato, no es caro, y es una herramienta importante de tener. Igual, seguramente, con el señor Cuarán. Nos escribe, por favor. Creo que era Cuarán. Sí, Freddy nos escribe al número de Alianza.
Ya.
Para poderle contactar y hacerle que le envíen a Quito su premio. No recuerdo si
es el que termina en
Quito.
Que en 277.
Sí, 0990-222277, el número de Alianza Agropecuaria. Y otra cosa importantísima, Freddy, es parte de, igual las dos personas que se ganaron el certificado. Evidentemente tiene que estarnos siguiendo, y si no nos está siguiendo, a correr a seguirnos en Facebook, en TikTok, en YouTube, en X, que se llamaba antes Twitter, a nosotros y a la empresa que nos va a facilitar el premio, por favor. Es parte de ganar, pues nosotros estamos buscando seguir creciendo y hacernos conocer. En este caso, usted se lleva el premio.
Ya.
Eso es lo más. Voy a dejar de grabar y ya, pues, cualquier cosa, seguimos conversando. Espero verlos en un siguiente webinar.